In this video, we're going to take a look at a uniform motion problem that was requested by a YouTube user. This video I would call, or this type of problem I would call kind of one of the classics where we have two trains traveling and blah, 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 that type of problem. This is kind of what we've got going here. So let's give it a look and we'll see what we can do. A red car left the park at 9 a.m. An hour later, a blue car left the same park, heading into the same destination. Both cars arrived at the destination at 1 p.m., and the speed of the blue car was 15 miles per hour faster than the speed of the red car. What was the speed of the blue car? Okay, lots of information here that we're given. So the first thing I want to do is just kind of pick out some of the information. We've got a red car and we've got a blue car. Okay, so two different cars. The red car left at 9 a.m. and the blue car left the same park an hour later. So that hour later, that means the blue car is leaving at 10 a.m. Okay, so let's kind of note that. And they're going to the same destination. So that's going to be important, I think. They both arrived at 1 p.m. The speed of the blue car was 15 miles per hour faster than the speed of the red car. So 15 miles per hour faster for the blue car. What was the speed of the blue car? Okay, so I think organizing this in kind of a picture can really help us. So let's just imagine that we have our trip right here, and the red car is starting right here, and I'm just going to label it red, and it's leaving at 9 a.m. Okay, and it's going to travel, and then it says that both cars arrive at 1 p.m. So when it gets over here, it's going to be 1 p.m. Okay, then we've got the blue car, which is going from the same place, but it leaves an hour later. So that means the blue car is leaving at 10 a.m. All right, so far so good. Again, they arrive at the same time. They both get over here at 1 p.m. Well, then we need to deal with the speeds. It says the speed of the blue car was 15 miles per hour faster than the speed of the red car. So we don't know either one. So let's call one of them X. Let's call the red one X. And let's call the blue one, well, if it's 15 miles per hour faster than the red one, we'd be looking at X plus 15. Okay. Now, we're traveling and we're going over a distance. Do you hear something in there? Distance. I think we got the distance formula going on. Distance equals rate times time. We don't know what the distance is, but we do know that they both traveled the same distance. So that might be helpful for us. In fact, we do know the rate. We've got X for the red car and X plus 15 for the blue car. And we can figure out the amount of time that they travel, right? So the red car, let's focus on the red car first. And we have the distance. That's going to be, we're going to set those equal to each other here. But we have the rate, which is X, and the amount of time. How long is it from 9 a.m. to 1 p.m.? Well, 9 a.m. then be 10 a.m. is 1, 11, 12, and 1. That would be 4 hours. So the red car traveled for 4 hours at X miles per hour. Okay. And then the blue car is going to travel. They're going faster. They're going X plus 15, and they're traveling for 1 less hour. So the blue car is only traveling for 3 hours, and they are going X plus 15 miles per hour. Okay. Now, this rate times time right here, I flipped them. The rate is actually the X piece, and the 4 and the 3 is the time, but We can do that, right? The distance is the same. So we're just going to set these equal to each other and solve that equation. We got this. All right, so we have, I'm going to distribute this 3 through here, and then I'm going to write it up here. So we have 4x equals 3x plus 3 times 15 is 45. All right, then we subtract 3x from both sides. That's going to give us, ooh, nice, x equals 45. Okay, so what is that? Now, this is where it's nice to have that picture so we know what on earth did x stand for. X, that 45, is the speed of the red car right there. So we know the red car was traveling at 45 miles per hour. It didn't ask us for that, but that might be handy. It's just some good information. And it's helpful to us because look at the blue car. It's x plus 15. And now we know what x is. So I can just go ahead, plug in that 45 there, and we find, sure enough, the blue car was traveling at 60 miles per hour. Now, how could we check this and make sure we're good? Well, what we could do is figure out the distance that was traveled. So if we went 45 miles per hour for 4 hours, that would be 180 miles traveled. So as long as the blue car traveled 180 miles in that time as well, we know that we're correct. So 60 miles per hour, and we're traveling for 3 hours. 3 times 60 is also 180. And so we should feel really good that we got this figured out. And answering the question, what was the speed of the blue car? 60 miles per hour. We figured out some other stuff as well, but that was what the question was asking for. So, uniform motion, the big key is about the distance formula right there. Distance equals rate times time. Organize the information that you're given, maybe draw a picture, something like this. Then we can write an equation. There's usually a couple things that are going to be equal to each other that we can set up, and then we solve. Remembering what that variable stands for, we can then get what we're interested in. I hope this video is helpful. These uniform motion problems can be a little bit confusing, but if you work them carefully, organize your information, you got this.